So thank you for attending this talk today. Thank you. Appreciate that. So my name is Zohaib Hhan, and just a bit of introduction about me. I am the practice lead in Red Hat Consulting for application migration and modernization. What that means is I basically work with the customers to implement Red Hat technologies in the field. I have with me my co-presenter, Malik from Verizon. He's a senior manager at Verizon's digital architecture. So he's going to talk about Verizon's journey with legacy modernization. So let's get started. So before I start talking about how actually we did this, you guys might have seen this. So for people who don't really know the history, generally enterprise IT lags in adoption of emerging technologies, right? Everybody else, the dot-coms and the Facebook and Google are the ones who break the barrier, and they are the ones who start this trend, and then enterprise IT is they are in denial, and then eventually when they see the value, everybody catches on to it. That's just the reality. I just wanted to open with that because we know that enterprise IT will adopt a technology at its maturity, right? Everybody wants to see what is the return on investment, and that's a key decision. So this is not a reflection, we are not judging anyone, but that's really how it happens. Now, why modernization is important for enterprise? So a few things I want to talk about are, first of all, modernization enables experimental approach to product development, right? In traditional sense, companies develop software products, and generally the way that software has been developed is you have a kitchen sink, and you throw everything in the kitchen sink, give it a 9-month release cycle, and you shake it, and something comes out, and it may or may not work, right? Essentially. And by the time that, so by the time something gets deployed, chances are that it will work. And if it doesn't, then you have another 9 months to fix it, right? So that has been going on for a while. But now, we know that everybody's challenged. There are Ubers out there for every industry, and people are thinking really, okay, we really have to make this work now, right? So one of the key focus for software development now is how can we actually get software in front of the customer quickly, iterate that, and then create a feedback loop and re-deliver it again and improve the quality quickly. So one of the key tenets for modernization is to actually enable that cycle. Optimize for cost versus speed. So if you are a traditional enterprise, chances are that you are optimizing for cost, where you have horizontal teams and you have outsourced a lot of stuff. Whereas, when it comes to software, speed of delivery is now taking a front seat. And also, modernization is now becoming a key catalyst for enabling enterprises for transformation. But changing systems is really hard. You have a portfolio of tens of or hundreds of systems in IT, and suddenly, you're tasked to convert everything to microservices or convert everything to containers, right? Yeah, it sounds good on paper, but how can you actually do that in a structured manner so that you can continue to deliver value to the customer, but at the same time, innovate your product portfolio? So certain things that actually get in the way are organizational inertia, skill sets, processes, and mindset. Sizable investments exist in the IT portfolio, so it's not practical to shut down those systems and just write everything from scratch. Oftentimes, modernization actually goes into uncharted territory, right? We love to talk about containers and we love to talk about new technology, but let's be real, for enterprise IT, these are still pretty unknown in terms of adoption at scale, right? Very few enterprises are now running this in production, right? And then the business perception is modernization efforts is like a black hole, that they spend the money and they throw good money after bad, and certain promises are made, and very little, comes out of it. Let's be real about it, right? So that's why there's this apprehension about modernization. I like to just talk about in general, like how the landscape has been over the past few years. So if you look at on the left, we used to take months to deliver right software and decades to run it. And the development process, architectures, frameworks, and infrastructure that enabled us, monolithic applications, physical servers, waterfall. And then it took us months and weeks to develop the software. And before we introduced change, it was years, right? That was the life cycle. And everybody started doing Agile, N-tier architecture, virtual servers, so on and so forth. But now, everything has to run on this guy. And by the way, you have to have an update every week or every 2 weeks. So it's really like you have days to deliver, and you only have weeks before you introduce new change. Now, the pressure is on IT to deliver that speed and the way certain technologies and processes enable that we have talked about, DevOps, microservices, and containers. I'm not saying that you have to take it all in one shot, but the whole point is that the IT has to navigate through this landscape to make sense of where they stand and then draft their roadmap towards what's going to enable them to deliver at speed, right? And that's what we do with the customers day in and day out. So now that we have talked about why modernization is important and what's really the value of it, wouldn't it be nice if there's a structured way to do this rather than a magic wand, somebody says that I'm going to make everything happen and something happens, but not really. By working with a lot of customers in the field, we have actually distilled our methodology into 3 patterns that I just want to go through quickly. And we have applied that pattern in Verizon's case. And Malik is going to talk about that application. Excuse me. So when it comes to modernizing the workloads, there are really 3 distinct patterns that we have figured out. Of course, there are others that I'm not going to talk about that deal with infrastructure and the overall data center. The focus over here is the applications, right? So we have lift and shift, in which we actually take the applications and convert them, their runtimes. We have refactor, where we take the existing applications, treat them as a back-end legacy system, and then innovate from inside out. And then we have a complete rewrite. What makes them different is the starting points. So for lift and shift, we start with either a well-architected application that have true separation of concerns. And the whole point is that the components can be independently containerized into different units that can be deployed independently. Similarly, refactor is about you have a legacy system that's hard to change. If you make one change, something else breaks. So how do you actually take that model and innovate from inside out? Basically, you treat the legacy system as a backend and start to build services from outside. And I'm going to show what that looks like. And the rewrite is about taking the legacy, which is at the end of life, and instead of saying that I'm going to just shut down the switch, how do you actually create feature parity, which is very, very important. When you decide to retire a system, you still want certain features that the business wants in the new system, and how do you actually go about doing that? So, so the lift and shift, generally we figure out a starting point, which is where your applications are, and then we define the end state. So in this particular case, I'm showing a microservices and API. That's where everybody wants to go, let's say. So the first step usually is you leave your data stores, your configurations, and your messaging middleware untouched, and you start to containerize or modernize really the components of the application, which, as I said, should be fairly well architected to begin with. That's really the starting point for lift and shift. And once you have reached this midpoint, this could be one step, this could be a series of steps, but the whole idea is that there's a midpoint in between that would allow you to deliver functionality to the business without shutting down the system, right? And once you're there, you can then refactor your way out towards the end state. I talked about the refactor. In this particular case, you have a system which is difficult to enhance or create new features for, but the business wants mobile integration, partner integration, or new features. So we recommend you leave the system untouched, but you basically create two integration points, one for the functionality, other for the data, and then you build the new functionality on top using hopefully like a container platform like OpenShift, and then deliver business value. The whole idea is that you have now enabled yourself to deliver value to the business without actually shutting down the system. That's still functional, you're using it, but now you're delivering new value. And as a result, you're not telling the business that give me 9 months shutting down the system, and then I'm going to write something new, and maybe you will see something, right? No, you are actually telling them that I'm going to continue to deliver value while we innovate at the same time. And once we are here, then we can draft our way towards the future state. And similarly, the third one is the rewrite. What I told about this was, if this is the system that you can do very little about because of the end of life, or because the vendor who is supporting this is not supporting the platform anymore, and you have to really get out of it, the main thing is that you have to create feature parity. So you just don't blindly start rewriting the new system. You inventory the existing system, prioritize the features that the business wants, and then basically, once you have a feature priority, then you can say, I can safely shut down the backend system. We have all seen situations where we have started to migrate or modernize, but then those legacy systems are still around because we never took the time to completely do the feature mapping from the old state to the new state. And as a result, even though the organization has spent the money in the new systems, yet you're still paying the old vendor. And as a result, it's a double whammy for you, right? So the whole idea is that we need to be really disciplined about rewriting the systems. And if you don't do this, then you will actually ending up twice the money instead of that. So just a quick comparison. Generally, people feel that rewrite is the fastest way to go. But in our experience, what we have seen is that a combination of lift and shift and augment is really where the speed happens. Rewrite is generally turns out to be a little more expensive because it's easy to get started, but hard to finish. Yes? So these dots I'm depicting based on what we have seen in terms of frequency. So we have seen a whole lot of lift and shift and augment versus the rewrite that have fully completed in the field. So this is just for the illustration purposes, but when I looked at 3 years of data across Red Hat consulting projects, this is the pattern that I saw, and that's what it turns out to be. So basically what it boils down to is that it's easier to get started with lift and shift and deliver as the first step as opposed to rewrite. Because I have seen that people would like to jump on a new platform right away and start rewriting the new code. It's very easy to get started, but it's very hard to finish. And these dots actually represent the point of actual delivery in production. So it does not represent the starting effort. It actually defines what we have delivered of value to the business. So, okay. So we have talked about the patterns, a structured way, and I'm now going to hand over to Malik, who's going to talk about Verizon's journey, how we have applied one of these patterns to their situation.
Thank you, folks, for the opportunity here. Before I go into the details, I would like to cover a little bit about what Verizon does as a business. I mean, nothing new here. At a very high level, we are distributed into three major verticals. One is the wireline business, wherein we sell Fios and the traditional phone line, tens and millions of customers in that area. Then we have our wireless business, where we sell in a cellular phone, cellular data, hundreds and millions of customers in that area. And then we also sell traditional internet to business all over the globe. So that's internet connected worldwide.
Yeah, my friend is actually being very humble. Verizon is the biggest telecom in US.
All right, thanks. I am the senior manager of the group. I have ownership for end-to-end digital architecture for the .com suite of properties, alongside with my boss, who's sitting there in that corner. So, if you have any recommendations after the call, you can go see him. Just to go a little bit into Verizon's history, Verizon's digital transformation started about say 15 years ago. I still remember that there was a dirty little web page that showed up somewhere, right? And all it had was call me number, call me, like the customer desk number, right? It was transformation was more considered to be connectivity over voice during those days. But over a period of time, now when people call our service desk, we say, hey, go back to the website. So we've tried to engineer the website so that it becomes more of a self-service engine for our customers. And one of the areas that we've picked up, and thanks to the Red Hat team and Zohaib to help us with this, is we picked up search as an example to showcase here for this use case. So when you go to Verizon.com and try to search something, right, you'll see a bunch of results. That's the application. It's a tier 1 Verizon application, very important for our customers, because a lot of customers come to us and we don't want to have them call us when they don't find information. So it's built on monolithic platform. It's a COTS product from one of a very famous vendors that I will not name for now. Lots of challenges with the way you work with monolithic applications. You run into environment lockdowns. Very typical of a development life cycle. You have a dev, you have a sit, you have a staging environment, right? So unless you go through that waterfall approach of taking your code base through the different tiers, you're not done with your work yet, right? Scaling, right? If you look at the application itself, some of the really old legacy applications are not cloud native. You have to have static IP addresses. The application might have specific areas where it might need to, you might not be able to do content pushes so easily because it might need to have all of that environment up at the same time, right? Proprietary items around the application itself that tie you back to the application. So now if I need to go cloud native, I really have to go call my vendor and say, hey, when are you going to deliver it so that I can become cloud native, right? And our releases are far apart, monthly releases. How do you deal with all of that? What that means is, very little automation throughout our development cycles, right? So what we tried to do was we tried to isolate pieces in containers. How could we move into the cloud, but at the same time not have to spend the time in refactoring the entire application? Because refactoring is a big thing, right? You're taking the entire application apart and writing it down into microservices or the smallest functionality available, right? How fast can we get to a state where we can have disposable environments, right? Where I don't have to have an environment up all the time, even though I'm not really using it, right? How do I get to auto scaling? In today's date, I provision my entire production environment to maximum capacity. And 80% of the times, I use it to minimum capacity. So that's hardware sitting out there, not being used. And that's a problem, right? Self-service, how do I eliminate the wait times around self-service, right? How do I have a seamless, continuous integration and continuous deployment cycle where, I can have the entirety of our development members be more productive, things around, open source technology. Am I open source? Am I logged in with a vendor? So these are all real-time problems, right? And wish list, public cloud, private cloud. Tomorrow, there's going to be something else if I want to bump off my buddy here, right, and move out from Red Hat to something else, right? How do I be platform independent, right? These are all the things as an enterprise when you start thinking about it, these are all the real-time problems that will come up. This is a standardized architecture for any multi-tiered application. What you see on the front is application servers and web servers that are responsible for running a lot of the business logic, if you will, right? And the business logic can be anything. If you're searching for, hey, my phone is bad, and I can throw you a shiny promo that says, buy a new phone, go, right? Don't worry about fixing your problem, right? Versus the massive index, very typical of search. You run a massive index in the back end, and then you have your logic that is presented to your end customers, right? And then the normal functionality of reporting. How do you see how your application is working? What is the rate at which you're serving your search queries to your customers, and so on and so forth. So this was kind of the architecture that we took, and we thought we would move it into a more cloud-native state without having to do all the rework that we landed up doing, right? Or we could have landed up doing. What you see here is a highly sophisticated, entirely containerized setup that was thrown on top of the OpenShift platform. You can see we had challenges around persistent volumes. That is very much necessary when you're doing something like a search application. Typical to search application, you have items around your front end, everything encompassed within Docker pods and Docker nodes. So with that, I'll hand it over to my friend Zohaib to come back and talk a little bit more in detail about this technology.
Thank you, Malik. So you saw this architecture, and we took literally this part that is highlighted in blue and converted into OpenShift. And now I know that everybody wants to see a big picture, so I have the next slide. Big picture, right? Without the heading. So in a nutshell, basically what we have done was took the pieces of the application, as you saw, and literally mapped one-on-one onto OpenShift. Now you can say, well, what's the whole point of having one container per node, right? I've heard that argument, but give us a break. This was the starting point, right? Lift and shift, right? We were taking the first step to realize the benefit of running into a container platform so that we can actually realize the potential of, delivering fast to the business. There were a lot of things that we had to figure out. First of all, as you saw, Malik talked about, this was a cards platform, right? No access to code base, right? So we had to literally containerize the bits, and I'm going to walk you through that. So actually, let's do a walkthrough of what that looks like. This is how we did. So in the first step, as you saw, we took unique bits of each pieces of architecture and converted them to Docker containers via the Dockerfiles, right? This was by far the most complex piece that we tackled early on because being a vendor product, not having the code base, we literally had to define what those layers would look like. So we start building those layers from the ground up. So we had to develop the Docker files for each one of these components. Next step was to convert these Docker images into pod definitions for OpenShift. So the way we do it is, if you're familiar with OpenShift, there's a template for each pod definition that you can actually write, and that makes it generic for your project. You can still write a specific template, but specific configuration, but we chose to write the pod because we wanted this to be repeatable, right? So we converted different pieces into different pod templates, and then these were then deployed onto different nodes. So as you can see that, we literally took the same mapping of nodes and mapped it into the OpenShift side of the things. The 3 templates actually went in that direction. So a lot of things that actually went into the template definition. Malik talked about static IPs. We literally had to figure out a way to solve that problem. And the way we did that was node port mapping. So in OpenShift, we would define a node port mapping that would allow this part of the architecture to still function as it is, but when it actually goes outside into the routing engine and stuff like that, OpenShift could assign different pods, so we had to define that. Similarly, we had to define the mapping from this side between this, so there was a hard IP address and port combination. So we had to solve this problem also. And the third challenge that we had to solve, as Malik was talking about for the indexing, was every index server had to have a specific persistent volume. It cannot take a generic. It had to be seeded with certain index to begin with, and then it would do some magic of its own, and then it would bring this whole cluster online. And by the way, for this system to function, all the nodes had to be up. Otherwise, this COTS application will mark this as unavailable. So we had to solve all these problems by defining the templates a certain way. So there was a little bit of hacking involved, but at the same time, it was the experimentation that we did, and we were finally able to actually produce this running system. And we did an internal demo, so this is what it looked like. So the Verizon page got up and running, as it was before the transformation started. And then, we were actually able to run the query. So you can see that when the user is typing the query, the drop-down appears as the suggestive, and then you see the search results for something that it was able to find and something that it was not able to find. Obviously, there's no Spider-Man, if you can see that, in Verizon. So it gives you that error report also. So coming back to, we talked about the architecture, we talked about the objectives. Let's take a look at the outcomes and how we actually, let's talk about how they map to what we started with and how we accomplished that. So.
Yeah, so I mean, for every proof of concept, there has to be an outcome, right? Is the outcome in our favor or not? And in this case, it definitely is. So, were we able to isolate pieces and separate them out, into containers and run them in Dockerized containers? And the answer to that is yes. But more than that, I think the biggest problem this solves is around the overall processes that you implement within your organization, right? Can you bring in non-production environments on demand, on the fly, and tear them apart once the work is done? And yes, you can do that. Can you auto-scale, right? There are workarounds around how you take a container and replicate it, go up, go down. But yes, those problems were solved. Self-service to eliminate wait times. That's a big thing, right?
How long were your initial wait times for infrastructure when you started?
Yeah, I mean, if you do not have a containerized environment and you are looking, obviously in today's date with AWS, spinning up instances is really fast. But in a traditional environment, if you were to go to a sysadmin and say, hey, build me a new machine, right? That always takes a certain amount of time, and it could be anywhere between a week, bare minimum, to a month, right? Depending on how many hoops he has to go within the processes. Out here, it's already there. You just have to click a couple of buttons and your container gets provisioned on the fly. So that's where the on-demand, plays a big role, right? We spoke a little bit about auto-scaling, right? But let us take a look at how we went forward with our releases in the new process, right? In the new process, we could bring in additional nodes with the new code that is going to be released, right? Put that out there for testing, do the quality assurance for that, and then you can make a determination whether you want to do a controlled release, like have 10% of the traffic go there, or all of a sudden switch all your 100% traffic to go into the new new boxes. So it's a very different paradigm altogether that we brought on board with this proof of concept here.
By the way, this is an example of a rolling upgrade. And when we saw Malik, when we demoed to Malik's team, he was like, "Wow, this is what." You know, I think I could see your face,
Yep.
you know, the reaction.
Yeah,
Yes.
this is a,
Pure Docker files.
one more? Okay.
Well, you're going to see the complete slide after this.
All right. And can we do this with open source technology? Yes, OpenShift is open source technology. Are we locked into any vendor? Given the situation, that we are containerized, we're not, but we still have items within our container. But to be honest, we could take those containers and throw them anywhere, right? Doesn't necessarily have to be.
Yeah, those are first-class
right?
Docker containers, so
Yep.
they can run anywhere.
Yep, and that makes us portable across clouds. So if we are to push this on a public cloud of choice, there are a couple of choices out there. You can toggle between public clouds as well if that's what you want to do. So that's quite a bit of flexibility right there, and that's very powerful, I feel. With that, I think we'll open up for
So
questions.
we deliberately wanted fewer slides for this. I can talk about the methodology and how we do it. I have some supplemental slides, but we want to open for questions. I know that there's a lot of interest in this, so. Well, it really solved the problem of environment lockdown and having maximum capacity all the time. So that was a clear win. And do you have any specifics that you want to add with respect to the cost savings or anything that you saw specifically?
Yeah, so like I said, when you provision for maximum capacity. So I could, just to give you an example, I might only need one box to function to serve the requests that come in the middle of the night, all through the night. But as I go into the morning, I need better horsepower, right? So that kind of scaling, auto-scaling capabilities are there, and those capabilities add on to the dollar value. It's a direct cost saving. And even an example of, like building a non-production environment, right? If I know that there is a release cycle going in this week, and then the development team is going to shift on to something very different next month, I don't need to keep it provisioned, right? I can turn it off and then bring it right back on when I actually need it. So, and it's just embedded within the process of OpenShift that when you have a release, you need a container, you need your code, you put them both together, marry them, and have them go through the dev cycle. Once it goes to the dev cycle, you take that and that goes live. You decommission your prior production instances that were there. So it's a completely different paradigm altogether.
Yes. So this effort was like roughly 2 months, like for us to go from initial project scoping all the way to actually do this, because we were doing this for the first time, and OpenShift had to be set up. So really starting from zero. So roughly like 7 weeks to 8 weeks.
Oh, that's a very good question. Containerizing is not easy. It can differ for different environments. It can differ for different applications, right? But the good part is once you know how, if you do happen to have a persona of applications within your enterprise portfolio, say 100 of them fall in this bucket, right? You create that one container, and that container will apply to all 100 of them. So that kind of is a big advantage, but there's still going to be a one-time effort, like Zohaib mentioned, a 8-week effort for you to figure that out. What does it take to get that one successful container out there?
Now, just to make this process more repeatable, I was just going to talk about our process. So the way we actually do it for the entire portfolio is that, I'm not sure if you can see this. So we actually take the catalog of all your applications and prioritize on the basis of complexity, right? So we have a tool called Windup. that is now, we are field testing cloud assessment rules as part of this. And what is going to come out of this is the readiness of the application to be modernized on OpenShift platform. And this is going to give us a very good starting point in terms of, whether this is a high complexity application, medium, low complexity. And that's how we can actually define these different buckets and create a plan of action for these. And we can actually scale up this effort by creating parallel execution teams. So from that plan, and this is how we actually do it by a factory model. So if there's a large portfolio of applications, we are not going to do this just for one application. We will do a POC or a pilot, but then in order to scale up, we have a methodology and process to go do it in much more structured fashion. And then lastly but not least, we also have a roadmap that we work with the customer. So if you are coming to us with a portfolio of applications, we can actually work with you, sit down and make an assessment and then give you the starting points and the desired state and all the steps in between. So it's very prescriptive.
Is that wind-up app yours?
Yes, so it actually came from the Red Hat Consulting, and then we open sourced it, and now we are working with our team to actually enhance it for cloud assessment. So you can go to Windup to download it. Yes. So since the target state is OpenShift, obviously this is going to be Red Hat Linux. Yes.
The OS that originally supported the application was already...
Well, it doesn't have to be. So the application could be a Solaris one, as long as, let's say, so if it runs Java, for example, that will be the lowest common denominator for us. So we can run Java, equivalent of that. We will do that mapping for you. So if you're running Solaris with Sun JDK, for example, we will do a Red Hat Linux, equivalent Red Hat Linux stack with OpenJDK, for example, just to make sure that the feature parity exists, and we will support it. So.
You must have done it. You had web logic in there.
Yeah. So this application had the session replication and all that. So we had to, the way we defined our template for the front end actually had this thing. So session replication was done via the Oracle database, right? In your particular case for this application, if I remember correctly.
No, there was no session replication.
There was no. Okay,
yeah.
I see.
There is a concept of session persistence, but that's handled on the load balancer end.
Right. To be honest, since we were looking at the carts application, we really had to solve the first problem of containerizing it and defining that strategy. So we could not do S2I, partly because there was no complete source code. There was source code for the bits that Verizon have put the customization in, but there was no source code for the index server or the management console. That was the hardest bit. And there was a lot of research, back and forth testing that we did to solve that first. Once we had the base containers that could run, then we start working with the Verizon team to define the configuration bits and all that. So for this particular effort, it was mostly manual, but we actually prepared a whole stack strategy. It's like what will be the base layer, like base rel image, and then the JDK on top of it, and then the framework, and then the container, the application container on top of it. But we are thinking of adding this capability to wind up, in future that, if we are successful in, rolling out a complete assessment of the cloud, well, when, we might also spit out some Docker files as a sample, and that's the direction we want to explore. So this is something that we identified early on, and I'm glad you asked that question. For everyone who is thinking of doing something like this in some shape or form, first thing is that please talk to your vendor who provides that platform to make sure, A, do they support Docker? If they do, then the first step is really short-circuited. They might have the Docker containers for you to begin with, right? And B, the licensing model that they support. So I don't think they're going to say anything if you're experimenting internally, but before you put something in production, please go ahead and talk to them, because obviously we don't want you to get into trouble, but at the same time, when you deploy something to production, you want this to be supported, right? You don't want this to be unsupported. And Red Hat will do their level best to identify the problem if we do not own the stack and point you to the right direction. But just don't put anything into production before talking to your vendor, just in case, as a good practice. So in this particular case, it was a file store, like a drive, and the indexing server actually created its own set of files. So it was like a NFS volume in Kubernetes. Yeah. PVs, if you're familiar, persistent volume framework in Kubernetes. This is still a tiered system with the firewalls in between. So the database access was still going through that, the third layer. So this was deployed in a network zone which was still secure, but the database was still behind that. So there was no way for anybody to actually hit the database directly. So yeah, I mean, security is one of the things that you have to solve for as part of the initial approach. Oh, don't get me started. When we prepared the Docker file, literally there was an install wizard that had to run for the installing of that COTS application. Now, I mean, it took us some experimentation to get to that point, but so it wasn't like we could just lift the binaries and deploy, wrap into a Docker container and call it a Docker image. It didn't work like that. We actually tried that. In order for us to prepare the Docker container, it had to start from the installable setup file that the vendor provided, and that runs a wizard. And I was like, am I going to run a wizard as part of Docker creation, Docker file, in the Docker file? But it turned out that we had to, and that wizard had to do the install of pieces in the specific directories, because if it didn't, then it was very hard for us to lift those pieces in a Docker image.
That's a very, very good question, actually. No, we did not have enough knowledge or even team strength with respect to OpenShift and all the technology around it, right? But with the 8-week engagement, there were a couple of members from my team, and there was a big list of team members from Zohaib's team. So for us,
there were a lot of doubts. Like, can we get the environment up and running yet? Don't deliver this. So, but we had to have consulting team come in, nail down the environment, then do this. So, yes, it was. I'm part of consulting, by the way. So my team actually does that. So do you have visibility into backups, like how your applications?
No, since this was a proof of concept, we didn't really think about backing anything up. We didn't.
Well, to be fair, like this whole setup was created in NFS volumes that were backed up daily. So they are looking at the portfolio of applications to actually modernize as a result of this.
Yep.
So this served as the test. So that's a broad topic. So why don't you talk to me after this? There's a reference architecture that I can point you to, and there are a few other things that we can talk about. Any other questions? There are a lot. Okay. All right. So we're going to be hanging out for another 5-10 minutes. So if you want, you can ask any questions. Thank you.